Welcome to Math Master. This is Saritha. We will continue the topic of circles. So, yesterday we have discussed all the properties of chords. Yes. Now, we will discuss what is a semicircle. Semicircle. See, if you take a circle and if you, this is the center of the circle, right? This is a diameter of a circle, isn't it? This is the diameter of a circle, and these are end points of a diameter. If this is a AB diameter, these A and B are end points of a diameter. These end points of a diameter divide this entire circle into two equal parts, isn't it? So this is like, yes, this is one part, this is another part. Yes, both are equal parts. That is why the end points of the diameter divide the circle into two equal parts, and these two are equal, and each part we call it as a semicircle. Yes, this is a semicircle. This is a semicircle. This is also a semicircle. Okay. Our next definition is arc. Arc of a circle. What is an arc of a circle? See, if you take a circle and any part of a circle is called arc of a circle. See, if you take, this is a part of a circle. Okay, and these 2 points I am saying AB points, and this is a, what about this? This is a part of a circle, isn't it? Yes, this is a part of a circle. This we call it as a arc of a circle. Yes, this is one arc, and this is another arc, isn't it? So, if you take any 2 points on the circle, so there is a chance of forming two arcs. One is small arc and one is big arc. And if the arc length is, if the length of the arc is smaller than the semicircle, then we call that arc as a minor arc. Yes, this is a minor arc because it is smaller than the semicircle. Okay. And if arc length is greater than the semicircle, then we call that arc as a major arc. See, this is a greater than semicircle. That is why we call this arc as a major arc. And we represent this arc with AB and arc symbol on the above of AB. So this is how we can represent arc AB. Okay. Then how can we, this minor arc can be represented by like this. What about the major arc? For both minor arc and major arc, the end points are same, right? So these AB points are end points of minor arc, as well as those are end points of major arc also. Then how can we represent major arc? See, you have to consider one point here, and you have to represent APB arc, which is nothing but it is a major arc. Okay, so this represents a major arc, this represents a minor arc. Okay, so just now we have seen that end points of both major arc and minor arc are same. Okay, now we will discuss angle subtended by an arc at the center of the circle. See, this is a center of the circle, and when we say this is a angle subtended by an arc, see, the end, if you join the end points of arc with the center, what happens? This is one end point I am joining with at the center, and this is one more end point I am joining it with center. Now the angle is formed, isn't it? So this angle we call it as an angle subtended by an arc AB at the center. Yes, this theta is an angle subtended by an arc AB at the center of the circle. Okay, and you see, as this is one angle formed, this is another angle also formed at the center. Yes, this I am calling it as a alpha. Okay, this is, you have seen that this is a major arc AB. Now you see we are joining endpoints of major arc to the center, and here angle is formed, and this alpha we call it as the angle subtended by an APB arc, because this angle is subtended by major arc, right? That is why we call this alpha angle as the angle subtended by a major arc APB. Okay, and you see, you observe what is the total angle at the center. The total angle at the center is 360 degrees. Yes. As this is theta, what about the remaining, which is always equal to 360 minus theta, right? Yes, this alpha is equal to 360 minus theta. What happens? You observe these two angles. One angle is theta and one more angle is 360 minus theta. If you add these two angles, you will get 360 degrees. What happens? These two angles, the angles subtended by major arc as well as minor arc, are always conjugate to each other, because their sum is 360 degrees. That is why the angles subtended by both major arc and minor arc are always conjugate to each other. Okay, and in this, so we have seen the angle subtended by both major arc and minor arc, right? So what about the angle subtended by the semicircle? This is a semicircle. Yes. So what is the angle subtended by this AB arc? Means semicircle is also nothing but a part of a circle, right? So that is, we can call it as arc also. So what is the angle subtended by this AB arc? Which is nothing but, if it is a center, so this is the angle, this is the angle subtended at the center, because we are joining the endpoints to here. So what is this angle? This is a straight angle 180 degrees, and this is also 180 degrees. So the angle subtended by semicircle at the center is always equal to 180 degrees. Okay. See, as this is a angle subtended by this arc at the center, if the same arc subtended the angle at any other part of the circle. See, if this is any point on the other part of the circle, if an angle subtends here, means if you join the endpoints of the arc with this point, and here angle is formed, isn't it? So we have to, and if this is the center, and we know that this angle, yes, yes, here here the angle theta is there, yes, and here also angle forms by the same arc. So this arc is subtending theta angle at the center, and this angle subtend alpha angle at other part of the circle. So what happens if you take other point on the circle, and here also one angle forms, here also one angle forms, yes. So these are all different types of, these are all angles formed by the same arc AB at other part of the circle. So what is the relation for the angle subtended at the center and angle subtended at any other part of the circle? So what is the theorem? The angle subtended at the center is always twice the angle subtended at any other part of the circle, which is, if this angle is, if this angle is theta, yes, if this angle is theta, and this is always twice of that angle. Yes, this is the relation between the angle subtended at the center and the angle subtended at any other part of the circle. So this is very important. So what is that? The angle subtended at the center of the circle is always twice the angle subtended at any other part of the circle. Okay, this is a circle. Now I am proving how the angle at the center by the same arc at the, means the angle subtended by the arc at the center is twice the angle subtended at any other part of the circle. Now we will prove. See, this is a center, okay, and this is an arc AB, okay. and this is an angle subtended by at the center. This I am taking as alpha. Okay, and here is any point on other part of the circle. Let us consider this as a P point. Now this is an angle subtended at the any other part of the circle. Okay, this is what I am taking an angle theta. Okay, if this total angle is equal to theta. Okay, see what I am doing. I am joining this center of the circle with any point on the circle. Okay, yes, I have joined. What happens here? This angle is divided into two parts. So one angle I am calling it as x degrees, one angle I am calling it as y degrees. Okay, so this is x degrees and this is y degrees. Okay, see this C point, this PC is equal to AC. Why? Because this is a radius of the circle, this is a radius of the circle, this is also a radius of the circle. That is why these three are equal, means PC is equal to AC is equal to BC. Okay, all are radii of the same circle, that is why they are equal. Okay, I am considering the triangle ACP. So in triangle ACP, the two sides are equal. What happens if two sides are equal? The angles opposite to equal sides are also equal, isn't it? So here the angle opposite to this side is x we have considered. So what about the angle opposite to this side? This is also x degrees, isn't it? And similarly these two sides are equal in the triangle BCP. So in the triangle BCP, here also these two sides are equal. What happens? The angles opposite to equal sides are also equal. Yes, the angle opposite to this side is y. And what about the angle opposite to this side? This is also y degrees. Yes, this is x degrees. This is x degrees. What about the angle here? This is a triangle, right? So the sum of the all three angles is always equal to 180 degrees, right? We know that the two angles are x plus x, which is nothing but 2x. What about the remaining angle, which must be 180 minus 2x? Yes, this is 180 minus 2x. Yes, and in this triangle, BCP triangle, what happens? What about this angle? Y. Two angles are given, that y, 2y. Sum is 2y. And what about the remaining angle? That is equal to 180 minus 2y. Yes, this is 180 minus 2y. Now, we know the angle at the center is always 360 degrees, isn't it? So, 180 minus 2x plus 180 minus 2y plus alpha. The sum of all these angles is equal to 360, right? Yes, 360 degrees. Now see 180 plus 180, 360, 360 gets cancelled. And 2x, 2y goes that side. 2x plus 2y, and which is equal to 2 times of x plus y, isn't it? But we know what is x plus y, which is equal to theta, right? So which is alpha is equal to 2 theta. This is how we can prove that the angle subtended by an arc AB at the center is twice the angle subtended at any other part of the circle. Okay? You observe this is a minor arc, right? So this minor arc makes an angle at the center which is always less than 180 degrees. You observe as this length of the arc is less than the semicircle. Semicircle makes an angle at the center is 180 degrees. But this length of the arc is small. That is why the angle subtended at the center of the circle is also small, which is less than 180 degrees, right? That is why the minor arc always makes an angle at the center is equal to less than 180 degrees. What about the major arc? This is always, this length of the arc is greater than the semicircle. So this makes an angle which is always greater than 180 degrees. isn't it? So this must be greater than 180 degrees. Means minor arc makes an angle at the center is always less than 180 degrees, and major arc at the subtends an angle at the center is always greater than 180 degrees. Okay. So these are some points about arc, and we will continue in the next video. Thank you.